Hello. So in this video, let's see problems in Regula Falsi method or method of false position. Both the names are same. So here, what is so special about this method? So here also we'll find the real root of transcendental equation. So what are those? So the equation that contains exponential function or log or trigonometric functions and so on. This we call it as an transcendental equation. And this is the formula: x is equal to a into f of b minus b into f of a by f of b minus f of a. Remember in the formula in the previous method, Newton-Raphson, if the initial value is not given, how to select the initial value? So I said the root lies between 2 points. So it means the root lies between a and b. So I've selected, we need two initial values to start this. So let's see a problem. Find the fourth root of 12 correct to 4 decimal places. So how to get the equation? So we don't know this. Assume that we don't know that what is fourth root of 12. Of course, you can calculate in calculator and you know the real answer. So x is equal to fourth root of 12. I don't know this. So x power 4. If I take x power 4, this will become 12, which implies x power 4 minus 12 is equal to 0. So from this, I frame the equation. So f of x is x power 4 minus 12. This is your f of x value. Now, I am going to substitute few values. Okay. For example, if I substitute 1 power 4 minus 12. So what is this? Minus 11, which is less than 0. Similarly, if I substitute 2, what is the answer? 2 power 4 minus 12. So this value is 16 minus 12, which is plus 4 greater than 0. So I got two values. One is less than 0. The other one is greater than 0. So why we are checking this? So the real roots are here. Okay. So these values will be positive and these values will be negative. So if I find a real root, then the root lies between one positive value and one negative value. So that is why we are doing this thing to find the initial approximation. And now you can check it in your calculator. What is fourth root of 12 value? So it is 1 point, I know this is going to be the answer, 1.86. So in such questions, the advantage is your answer is going to be closer to that. And of course, I said the root lies between 1 and 2. Of course, 1.86 is in between these two values. And please don't write root lies between minus 11 and 4. These are the function values. The corresponding x value only we will write. So a is equal to 1, b is equal to 2. And I'm just substituting the values. A into f of b minus b into f of a divided by f of b minus f of a. So already we have calculated, right? What is f of 2? I have 4 minus 2 into f of 1. First iteration is always easy. Minus 11 by f of b minus f of a. So this is my function value, and denominator it will become a positive value. So numerator 4 plus 22 divided by 15, and if you calculate the answer, this is nothing but 1.733. This is your first iteration. Similarly, you have to go for 2 to 3 iterations. Now, Newton-Raphson is very easy. Just we will take the previous value and we will proceed. But here for the second iteration, again I need one positive value and one negative value. Always one value remains the same, the other value keeps moving. Whatever value that we have got, right, I have to find f of that new value. So if I check the function value and it happened to be, you just wherever x is there, you substitute. Okay. So my function is x power 4 minus 12, right? So 1.733 power 4 minus 12. If you check this value is nothing but minus 2.97401. This value is less than 0 because it's a negative value. Correct? And what is the other value? Here out of a and b, this is less than 0, this is greater than 0. Since I got a value, better value than 1, which is closer to the root, I will take this as my A, and the second value I want one positive value. So f of 2 is 4, which is greater than 0. So my new A, or you can write A1, okay, whatever it is, new A, 1.733, and B remains the same. So what I'm trying to say is, for example, you are saying the root lies between 1 and 2. Your original answer is 1.86. It is somewhere here, your original answer. So now I'm saying that it's tough for me to search in this range. Now I'm finding 1.733. Okay, it should be even more closer. So let it be this 1.7. So if I say answer lies between these two, this is a closer window where I can search my real root. Okay, so this is your new A, this is your new B. Therefore, x is equal to A into f of B minus B into f of A divided by f of B minus f of A. So already these values are there. A is here, B is here, and then this is f of A, this is f of B. You have to substitute all these values here and simplify. You will get 1.84686. So this is, now it's coming closer, right? Now again, second iteration is over. For third iteration, what you should do? I have to check the function value of this 1.84686. And this happened to be a negative value, minus 0.36582. So this is negative. So this is less than 0. And f of 2 is positive, greater than 0. So root lies between 1.8486 and 2. So this is your new A and this is your new B. Again, 2, why I have written in brackets. So this is your new A and this is your new B. Again, you have to repeat the same process and you will get the answer as somewhat closer to 1.8468, because you know what is your real answer. What is your real answer that you have calculated in the beginning? So you guessed it 1.86. That is where you found it in the calculator. If you do more and more iteration, see now from 1 to 2, I have reduced to 1.73 to 2. Now it has been even further reduced to 1.84 to 2. So if you do more and more iterations, it will be almost closer to your original answer. Okay. So please be careful with the iteration. Sometimes first value remains the same, second value will keep changing. So I want to give you one problem for practicing. If you see this, find the real root of the equation tan x plus tan hx between 2 and 3. See, this is a hyperbolic function and you have to use radian measure because I didn't give an angle. So 2 and 3. So change your calculator to radian mode and solve this. And already they have given 2 and 3. So you can take A as 2 and B as 3 and perform the first iteration. And please check the answer. And if you know f of 2, you will get a negative answer. And f of 3, you will get a positive answer. Then only root lies between. They can give in the question itself. And you will get the answer after the first iteration as 2.588886. So if you want to truncate, you can write it as 2.5889. Okay. So using this, what you are going to do? Again, you have to find the function value. F of 2.5889. If it's positive or negative, you are finding. Okay. So if this value is opposite to, so f of 2 is negative and again this seems to be positive. So this is your new A, this is your new B. Again you are going to repeat the process and solve it on your own. And in the third iteration, again root lies between, you can solve it on your own, just check the answers. 2 and 2.45137. So it's coming even closer. So your final answer for x in this iteration is 2.39921. So if you notice here, what was the window in the beginning? 2 to 3. It's a big gap. My root lies between this. Now it's like searching for a jackpot. So it's a big distance, right? So 2 to 3 is tough. So in the second iteration, I'm saying better you search from 2.58 to 2. I'm saying that your answer, instead of searching the whole window, you search here. Now in the third iteration, I'm saying even I'm reducing this. So 2.45. I'm saying you search here. So instead of searching the entire period like this, I will be narrowing down this. So sometimes one value will keep fixed, right? So 2 is fixed, it is keep moving and you will go closer to the root. Practice more problems. Thank you.